Now we do the second part of calibration, where you attach the tracker or controller to the 3D camera itself. In this case, I kind of sticky taped and rubber banded a Vive controller to my Kinect camera, and then you want to calibrate the camera with respect to the controller moving with the controller. So this is sort of the opposite of the calibration we did in the other video. In order to set the program up to do it, you have to click on moving camera here, and then we also want to somewhat up the maximum inlier distance for the Extrinsic algorithm so that it has a better chance of converging. So I'm setting that to 2.5 centimeters right here. That should do fine. And then the idea is that with the controller attached to the camera, you just, in this case you don't have the disc, the calibration disc is the same disc, but you're not attaching it to the camera, but you're just putting it at some fixed point in space. Which particular point you choose doesn't matter. Here I just put it on some object to have it a little bit off the floor, and then everything else works the same. We point the camera in this case at the calibration target until it turns red, and then we press a button on the controller in order to capture a tie point. Here's one, and then you do the same thing. You capture a bunch of tie points from different points of view, different orientations, and if everything works well, it's going to create a calibration. Not quite yet. Maybe we need a few more tie points. Here we go. And so now I can center the image on the calibration that I created by resetting the view, and I'm going to zoom out a little bit. And so now what's going to happen is, no matter how I move the camera around, as long as tracking works, the calibration disk, as you see, will stay in the same position in space. And as in the other calibration mode, the blue or green-blue crosshairs should ideally line up exactly with the center of the disk. So in order to do that from throughout the space, we just keep taking additional tie points until everything locks into place. Here we go. That's already pretty good. And then another one from here, and one from here, and one from here, maybe at an angle, let's see, maybe like this, and one from up and straight down. The hardest part about this is actually attaching the controller to the camera so that they don't move with respect to each other. This would be easy if you had one of those Vive trackers. They have a mounting surface and actually a mounting hole at the bottom. That makes it really easy. Here I had to use a somewhat jerry-rigged combination of sticky tape and rubber bands, but it kind of works. And so as long as tracking works, you notice how I can now almost scan the room. I just move the camera around. Oops, here it lost me for a moment. Move the camera around and can, if I were to record all these depth images now, I could collect a pretty detailed 3D model of the room just by adding up all those depth images without even doing any more post-processing on that. Okay, here we go. That's a pretty good calibration from what it looks like. So we are doing the same thing as in the other calibration mode, where we just, when we have everything and we're happy with it, we go to the calibration control dialog and select save alignment, which then in this case will not save the position of the camera in world space, but it will save the position of the camera in controller space. But the next time you run Kinect Viewer, as usual, it will pick up that calibration right away. So if they didn't move the controller in the meantime, you'll be able to now do some moving camera mixed reality recording. Here we go. Nicely locked back into place, and that's it. So we can shut this down now and maybe do an example of what that looks like if I do a mixed reality recording with these calibrations.